Hello and welcome to yet another video. As you can see, I've got the logic protocol analyzer hooked up to the SPI lines on that flash chip that we discovered in the last video. I've also put the main processor board back in the air-cooled DMOC645, and we're going to fire it up and see what we see. We're going to sniff the SPI bus. I'm on the enable line, or the chip select, the clock, master in, slave out, and master out, slave in lines. And we're going to go ahead and flip her on here. Oh, you know, I should probably start capturing first. So we're going to start capturing, and then flip it on. And we'll wait for it to do its thing, and we're going to get a bunch of data. And I'm going to put this really close to see if it adjusts the contrast so it makes it easier to read, but apparently not. But we're done capturing, so we'll go ahead and zoom out and see what we find. And yep, lots of data. So, let me get my mouse here because this program zooms in wherever your mouse is at. So we'll go ahead and zoom in to the front here. First data packet. So I already know what most of these mean. Like here it's doing a 5, which is a read status register of the flash memory chip, and it's turning 0, which means it's not busy. So now that they've established it's not busy, they send 3, which is a read request at address 10000, so it's a 24-bit address, and then it returned FF, so they read 2 bytes out. Then they do the same thing, another status check. It says it's not busy, and then they do another read request. They send 3, and then 1, which is the first address, and then they got interrupted. And then finally it resumes over here with 0002, so they've incremented by 2, and they then get the next byte, which is word, which is FF, and so on and so forth. Rather than doing a continuous read, which this chip is fully capable of doing, they always send the address. So they always do a status register check, read request, put the 24-bit address on the bus, and then read 2 bytes or 1 word, 16-bit word. And because they do that, you end up with tons of transactions. And you can see all these breaks, and here's where the micro got interrupted, and that's why they don't do it a sequential read, because they're busy doing other services. And that is all of the EEPROM data. So there's a lot of it. Let me zoom out. You can see it essentially they read out the entire chip from flash into RAM on the micro on boot up, and then every once in a while you see these little ticks. They go and do, I think they're doing this is kind of typical of automotive and for aircraft specifically, where they do like an integrity check, where they go and they're just reading out a page and calculating its checksum, making sure that it's still good and we haven't corrupted any kind of one of the pages in flash or anything like that. So it just sits there, and every 5 seconds, I believe, it goes and reads out a page just to check it. So you can zoom in here to this little read. And you can see they do the same thing, where they're now checking this is address, so they're doing a read request 12A00, and they're just reading it out and checking with what they've got stored in RAM, because they've already read that byte or that address, and then the next one, so on and so forth. They just keep doing that. So here's the next address is 12A04, so on and so forth, just to make sure that what they've got in RAM matches what they've got in flash, and vice versa. So if there's an error, I would assume that they would correct it somehow. It does have a cyclic redundancy check, so they should be able to recover a few bit errors. But anyways, this video is kind of long, so I'm going to go ahead and stop it here. And the next one, we're going to record writing to the EEPROM so we can see what that looks like. Anyways, thanks for watching.